All right, so with two-step equations, again, you're just performing two inverse operations in order to be able to solve for the variable, the missing value. And we've got a couple of different setups or scenarios for two-step equations. So again, with the two-step, it's just two simple rules to follow when solving two-step equations. So we're going to focus on scenario 1, which is probably the more common one that you guys are going to see this year. We use it a lot with geometry, and it's just basically your typical situation where it looks like the following. Like if we have 2x plus 3 is equal to 23. Okay, so this is your typical scenario 1 two-step equation where step 1, again, it's 2 steps. Your very first step is to do your inverse operation to the constant. That basically means that you're going to add or subtract your number value first. So you're going to add or subtract first. So if I have, again, like we said, we've got that 2x plus 3 is equal to 23. Am I going to add or subtract for my inverse operation? Jimmy? Subtract. Because right now I see addition, so my inverse of that addition is going to be subtraction. So we're going to subtract first. Now, when I subtract, that plus 3 is now going to be canceled by that subtraction of 3. So I'm then left with 2x is now equal to 20, because 23 minus 3 is 20. And look what happens. Now we have a one-step equation. And you know how to solve these one-step equations. So that's when we get into step 2. Because our first step was to add or subtract, our second step is always going to be to do the inverse operation of your coefficient or your divisor, depending on how it's set up. So we'll do the inverse operation to the coefficient or divisor. And that basically means you're going to divide or multiply. Okay, so if we have that 2x is equal to 20, what inverse operation would we be performing here? Division, right? This was multiplication. That means we need to divide. So we're going to divide by 2 on both sides of that equal sign. The 2's will simplify out. It'll simplify to a coefficient of a 1. And that means we'd get x is now equal to 10. And you can always check it. You can always take the value of 10 and plug it back into the original equation. Our original equation was 2 times x plus 3 is equal to 23. We could do 2 times 10, which is 20, plus 3 gives us 23. You can always plug it back in or substitute it back in to check. So again, with scenario 1, you're going to add or subtract first for your inverse operation. Then you're going to multiply or divide second. So let's say that we have 2n plus 15 is equal to Oh, I'm so sorry. Is equal to 29. 2n plus 15 is equal to 29. So like we said before, our first step is to either add or subtract. Are we going to add or subtract in this problem? Olivia? Subtract. And what are we going to subtract from both sides? Go ahead, Olivia. Subtract 15. Good. So we're going to subtract 15 from 15. We're going to subtract 15 from 29. Okay, the 15s will go ahead and zero pair out. They're going to cancel out, so we can cross them off. That now leaves us with 2n on the left side and 14 on the right side. So step 2, are we going to multiply or divide? Mohammed. Divide. So we're going to divide both sides by 2. We're going to divide both sides by 2. The 2's will simplify to a coefficient of a 1. And n is now going to be equal to what? What's 14 divided by 2? 7. Okay. Let's try another one. Go ahead and go to page 48 of your notebook, please. Okay, so for page 48, problem number 2, let's say we have 8 plus x over 4, and it equals 17. Now again, we're going to do an inverse operation of adding or subtracting. So what are we going to do? Andy? Not x over 4. Remember, we want to focus on the constant. So which value is the constant? 4 is not a constant. Stephania? 8. Now, the reason we subtract is not because of this plus sign, but it's because if we don't have something written in front of it, 8, what do we automatically know is there? A plus, right? We automatically know that there is a plus sign in front of it. Because there is a plus sign in front of it, we would subtract the 8. That's why I also could rewrite this problem as x over 4 plus 8. It'd be perfectly fine to write it that way. So we're going to subtract 8 from both sides. That will help to get rid of the 8s, right? We can zero pair those out, cancel them out. That leaves us now with a positive. Notice I'm indicating that this is a positive because the plus sign in front. We're left with a positive x over 4. And it's going to be equal to what? What's 17 minus 8? Olivia? 9. So 17 minus 8 is going to give us the 9. Now, what inverse operation are we going to perform here, Safara? Multiplication. We're going to go ahead and multiply both sides by 4. We're going to multiply both of the sides by 4. So if I multiply by 4 and then I divide by a 4, it's like the 4 never happened. 4 times x is 4x. Divide by 4 and you just get x. So x is now isolated. And then what is 9 times 4 going to give us? Craig? 36. Yes, Jimmy? Well, we haven't gotten into fraction use yet. We'll talk about fractions not today. I want to focus on the concept first. Then we'll imply some fractions and decimals in there as well, okay? All right, let's say that we have 20 is equal to 5 minus 3n. This is very important that you focus carefully on that question. We're adding or subtracting. Which one is it going to be? Olivia? And that would be the typical answer most people would say. She said she wants to say add. However, if I add 5, is that going to get rid of this 5? Why not? Why will 5 plus 5 not work, Antoni? Because the 5 doesn't have a negative in front of it. What does it have in front of it? A positive. So that minus sign doesn't belong to the 5. Remember, we talked about your operations belong to the value it's in front of. So really that minus sign belongs to what? The 3n. That minus sign belongs to the 3n. The 5 is technically got a plus sign in front of it. So what would be the inverse operation to get rid of that 5, Zoe? Subtraction. You would have to subtract 5 from both sides of the equal sign. So we're going to subtract 5 here and subtract a 5 from the 20. So 20 minus 5 is going to give us 15. And what am I going to have on my right side? Olivia? Negative 3n. That minus sign has to come down, and it now is going to act like a negative sign. That minus sign comes down, and now since it doesn't have anything in front of it, that minus now pretends to be a negative. It acts as a negative. So we're focusing on 15 is equal to negative 3n. What inverse operation will we perform there? Camden? Division. And we're going to divide both sides by what? Not just 3, but negative 3. We're going to divide both sides by negative 3. So a negative 3 divided by negative 3 will simplify to a 1. So we now have a coefficient of a 1. And what is 15 divided by negative 3? Ryan? Negative 5. Good. And there's our final answer. So be really careful or mindful of problems like number 3. Put a big star by it so that you're very cautious when you've got a problem like that. All right, I want to show you scenario 2 now. Oops. All right, scenario 2. With scenario 2, you're going to have either parentheses or you're going to have a problem in a fraction. Not just that you have a fraction, but you actually have like a physical problem inside the fraction, like x plus 7 is inside the fraction. So maybe it's x plus 7 is the numerator and the denominator is a 3. So that would be a problem that's inside the fraction. Or you have parentheses with a value outside of it, which we know is the distributive property. But because we're talking about just 2 steps, we wouldn't actually distribute to solve. You could, and that would make it a multi-step problem, or you could solve it in just 2 steps. So if we had a problem like 3x or 3 times the quantity of x plus 5. So x plus 5 is inside parentheses. The 3 is outside of it. And it equals 45. In a problem like this, your very first step here, so step 1, notice I'm doing these ones in purple, and I'm going to do purple and orange. The other ones I did in pink and green. These ones I'm going to do in purple and orange so that we can see that there's a difference in the types of way we solve them. So for step 1, you're going to multiply or divide. First. So in this case, the way that this problem is written, is this multiplication or division right now? Multiplication, right? Because it's distributive property. Distributive property means we would multiply to each component on the inside, 3 times x and 3 times 5. So instead of multiplying, what will I do? Division. I'm going to divide. So instead of multiplying the 3, I'm going to go ahead and divide by the 3. Instead of multiplying by the 3, I'm going to divide by the 3. So the 3's will get canceled out on this side, or simplified out. And now here I'm left with x plus 5 on the left side and 15 on the right side, because 45 divided by 3 is going to give us 15. Then I move on to step 2. Step 2 is to add or subtract. So we use addition or subtraction with the constant. So we did have the problem x plus 5 is equal to 15. Are we going to add or subtract for our inverse? Subtract, right? If it's x plus 5, I want to go ahead and subtract 5 from both sides. And what will that leave x equaling? 10. And again, you could substitute that in. Substitute it in. You would have to do 10 plus 5 first, which is 15, and 15 times 3 would give you 45. So in our scenario 1, we add and subtract first, then we multiply or divide second. In scenario type 2, we multiply or divide first, then add or subtract second. Go ahead and go to page 49 in your notebook. So like I told you, it could be a problem with scenario 2. It could have parentheses, or it could have an actual problem inside of your fraction. So if we had something like x minus 7, all of that over 2, and it's equal to negative 9. Again, like I said before, you would multiply or divide first. Right, step 1, multiply or divide first. So right now, do we see multiplication or division occurring in this problem? Division, right? We see a division of 2. When it says, over 2, that means it's division of 2. So instead of dividing by 2, we're going to go ahead and multiply by 2. We're going to multiply by the 2 onto both sides. So multiplying by 2 and then dividing by the 2 simplifies those out. You're left with x minus 7 is equal to negative 18. And then just like before, step 2 is going to be to add or subtract. So are we going to add or subtract in the problem x minus 7 equals negative 18? Olivia? You're going to add. Good. So we're going to add 7 to both sides. I'm going to add 7 to both sides of the equal sign. So that minus 7 is now canceled out by the plus 7. And what will x equal? What's negative 18 plus a positive 7 going to give us? Say it louder. Negative 11. Go ahead and try this one on your own. That's plus. That's a plus. It just got crossed. God bless you. All right, Landon, what did you get? Negative 4 is correct. Very good. First inverse operation that you would have to perform, you would have to divide both sides by 5. So if we divide both sides by 5, the 5s will simplify, leaving you with just n minus 2. Negative 30 divided by 5 will leave you with negative 6. Then the next step would be to add 2 to both sides. Negative 2, or that minus 2 and the plus 2 will cancel or zero out. And then when you add 2 to that negative 6, it's going to leave you with negative 4. Okay, let's try another one on your own. All right, Ryan, what'd you get? Not 5. Andrea? 20. Very good. It's going to be 20. So the first thing that we have to do here, Ryan, is we have to multiply both sides by that 7, right? Instead of dividing by the 7, we're going to go ahead and do the inverse, and we're going to multiply. So we're going to multiply both sides by 7. When I multiply by 7 here on the left side, that's going to go ahead and simplify it to a 1. When I multiply the 3 by the 7, I'm going to wind up getting a 21. So I now have the problem W plus 1 is equal to 21. Oh, good. I'm glad you found your mistake. The next thing we'll do is subtract the 1. And that'll give us W is equal to 20. So instead of adding the 1, we would subtract the 1 from both sides. Sebastian? Well, I multiplied by the 7, but that's not a multiplication right here, is it? I'm not multiplying 7 times 7. I'm multiplying this top by 7, but then I'm going to divide by 7. It's like it never happened, right? Remember we said before, if we did 7 times 2 and then divide by 7, that would just leave us with 2. It's almost like the 7's never happened. So multiplying and then dividing by the exact same number makes it as if they never happened to begin with. Okay? All right. Let's try another one. Be mindful of what process we have to do for this.
So you can almost say that you're like eliminating everything there, but you just leave the W.
Leave the W in the 1 when you bring it down to this step, and then you're eliminating the 1. All right, who can tell me what they got for X? Olivia?
I got
-9. Very good. What's the first inverse operation we have to do in a problem like this? Well, first of all, what scenario is this? Scenario 1 or scenario 2? Scenario 1. This is a scenario 1 kind of problem. So remember when we have it set up to where you've got no parentheses, there's no problem inside of a fraction, that's a scenario 1 kind of problem. So going back to your notes for scenario 1, we get rid of addition or subtraction first. Scenario 1, we're going to add or subtract first, and in this case, we're going to add. We're going to add 8 to both sides. In this case, we're going to add the 8 to both sides. That's going to leave us with negative 3x is equal to a positive 27. Then our second step, we're going to divide both sides by negative 3. We're going to divide both sides by that negative 3. so that we get x isolated, and 27 divided by negative 3 is negative 9. Okay, we're going to stop there.